My name is Gene Carter. I'm International Product Marketing for the LPC1700 products. We're going to be discussing the LPC1788 primarily today. That has an on-chip LCD graphic controller. But we use the same graphic controller for our ARM7 devices, for those of you who use the LPC2478. We also use it on our LPC1800, the newest Cortex-M3, and the LPC4300, which is our dual-core M4, M0 part, and on a soon-to-be-released other M4 devices. So we use the same IP, so anything we see here will easily run on any of those other cores. So here's a brief overview of the agenda. So we'll go through very quickly about the parts that have the LCD controller, as well as give you a quick demo running on the embedded artist board, including a home automation demo and a human machine interface industrial demo. Then I'll quickly go over emWin. For those of you who don't know, we licensed emWin for you, so as long as you use our part, you'll get it for free. Go through some of the features of emWin, and then give you a comparison of our GUI, the emWin GUI versus other free offerings that are out in the market. Go through a quick overview about what other LCD tools we offer. People like very nice displays, very interactive, intuitive displays. So now that's kind of going into other applications, including industrial applications. Customers are starting to demand better displays on these things. So there are some real challenges with that. It can really make the CPU work hard. It can be hard to develop, and it can be very expensive. So our solution is to offer Segger's emWin GUI library for free. So that's a pretty good solution, we think. So we're going to show you a couple of quick demos just to show you what emWin can do, and then we'll get into some more about the actual features of emWin. So this first one is a thermostat demo. It's the beginnings of a full home automation idea. So a thermostat, security, those kind of things. A couple of things I want to highlight on there is if you look, those tick buttons, there's a slider, there's text, clock, and then most importantly, the fan spinning around. So these are all done with the emWin, done very quickly. Dale whipped them up pretty fast, and I'll kind of show you how he did that a little bit later on. But the emWin includes widgets that you just drag and drop if you're using the GUI Builder. The animation is just a few fans that are basically being refreshed in that block. So you can create very quickly some pretty nice looking displays with very little effort and, as I mentioned, for free. Now the next demo that he's getting is a human-machine interface for an industrial type application. So it's based showing RPMs and PSIs monitoring, and where you can set some alarms to trigger at certain parts. You can see over there on the left-hand side there's some gauges that'll move up and down. There's sliders on there so you can change where the alarm settings are. And if you touch that, Dale, we can show the over on the right-hand side. You can see we're graphing this. So a lot of people are thinking about maybe creating some scopes or things like that. This is an example of some of the types of things that you can do with emWin very simply, very easily. So as I said, Dale will get into the home automation one a little bit more on how he developed that and show you a little bit how you can quickly do it as well. So we have a broad range of parts that this works on there. So those are LCD panels without the controller, without the buffers on chip. But we also have licensed it so you can use it with any part that doesn't have an LCD controller on it, where you want to interface to glass that has a controller, has the buffers all on it, and you just talk to it via SPI or I2C, in which case then all you need to use is one of our microcontrollers that has SPI or I2C, which is all of them. So emWin will work on any of these. The examples we have up right now that you can download are all built around the LCD controller on chip. But over the next few weeks, you'll see other examples with the parts without that talking over SPI. So stay tuned for that. But this is usable for all parts that we have. So emWin, why emWin? It's probably the most widely adopted graphics library in the entire industry. So it's popular, it's well debugged, it's very user-friendly. So that was really how we targeted Segger, and they were willing to get into this deal with us. So we think they're a great partner, and it's been a lot of enthusiasm in the market for it. But they also use very small resources. So as little as 200 bytes of RAM for a small system with up to from 6 to 25K of flash. And then for a larger, more comprehensive system, it's 20 to 60K of RAM, and then 30 to 60K of ROM, so flash. So what sets it apart from some of the other guys, I'll go through a competitive analysis for you in a couple slides, but there's a GUI builder so that you don't have to write in C. It's really a higher level drag and drop kind of thing. Font generators, image converters, we'll go through some of these things, but there's a lot of nice features that really make it very intuitive and user-friendly. And then it's pretty full-featured. So if you look at this block diagram, you'll see that there's a lot of features on this thing. So we've shown it as optional in emWin, that's how Segger terms it, but in our installers, all of these are supported. So any of these options that you want, they're all built into our installers for you to use whatever features you want from emWin. And I'll go through a few of these features in a little more detail. So anti-aliasing. If any of you ever tried to do some fonts in a display, if you don't have anti-aliasing, it can look very ragged, very choppy. So what anti-aliasing does is smooth these curves by blending in the background color with it. So you can see different stages of anti-aliasing going down in the C's, or on those lines there, the number of anti-aliasing, the higher the number, the more anti-aliasing involved. So you can see from number 1 being very ragged to number 6 looking very, very straight. Buffering. So one of the nice features of emWin is it does support double and triple buffering. So why do you care about that? Double buffering prevents flicker. So if in your refreshing, by having double buffering, basically you're having the images twice there, so it doesn't allow you to, it doesn't let the IC flicker on there. Downside on that is if you do want to do that, it does require 2 memory blocks. Triple buffering requires 3 memory blocks, but what does that bring you? Tearing. So tearing is shown there, that's an extreme case of tearing there on the bottom right-hand corner, but that shows an example of tearing on the LCD. So if you use the triple buffering that is a part of the emWin, then you can really get a very sharp display. Now, if you're using a very smaller display or lower resolution, you may not care about any of this, but you do have those options with our device with emWin. Okay, so one of the optional modules that we've included with this is Window Manager. So it basically allows you to do Windows. So makes it look like a Win application, using the multiple buffers and doing display drivers and motion support. So I'll show you an example of what you can do, but also what Window Manager is required if you want to do widgets. So on the examples we showed you sliders, we showed you tick boxes and things like that. Those are all widgets that are automatically included with the emWin, but you need to use the Window Manager to utilize those widgets. So here's an example, 3 examples of what Window Manager can do for you on the animation side. Maybe a little bit hard for you guys to see back there, but so you can see on the left-hand side fading in and out, in the middle an image moving in and out, and then on the right-hand side an image shifting from the left into the center. So these are all things that can be taken care of automatically in a window animation with the Window Manager for animation. Okay, so widgets. Here's an example of the kind of widgets that are included with the emWin library. So you can see buttons and sliders and drop-down menus and tick boxes and a wide array of different widgets that are included. This make it very easy to spice up your application. And then they are all customizable as well. You can add skin, you can make them semi-transparent. So whatever it is that you want to do to make your application look good. So this is useful. GUI Builder, you can't do everything that you can do with emWin with GUI Builder. So this is not the end-all of it, but it's a great way to start. If marketing comes to you on a Thursday and say, hey, Monday I'm going to have a management meeting and I need to show some display thing, can you get something for me? GUI Builder is a great way to kind of pull something up very quickly and have it looking very good. It won't have all the features that you want, but you basically just drag and drop, multiple dialogues going along, and you don't need to know anything about the C programming of this thing. Okay, so it's free. Usually when you hear free, you think it's not very fully featured. Well, one of the nice things is if you look at, compared to other free offerings, I put up one there from TI and Microchip, emWin is very, very full featured. So it does complex shapes, it does alpha blending, it does anti-aliasing, has all the image conversions. it really does everything that you could really need to do your graphics libraries, and is free. So this is not, we didn't give you some reduced feature set that you get for free. This is a really, really nice graphics library. But if you don't need really, really fancy, and you want to reduce the amount of overhead that's needed, we also provide a simple Windows interface manager we call Swim. So it gives you basic fonts, it gives you boxes, lines, colors, some basic colors. It's really, if you just want to do some really basic boxes, lines, things like that, this is more than sufficient, and it's also free. But if you want to do more elaborate widgets and displays and animation things, then you want to go with the emWin. But it all depends on what you want to do in your application. Just want to take a second to point out at the bottom there, LPCware. So for those of you who have never been to that site, we created a site called LPCware, which is really a technical community and allows you to get application examples. That's where you download emWin and Swim. That's where you can get forum support. You won't get any of the marketing fluff. It really is a technical-oriented, all the data sheets, everything you need, Simsys files, all of it is there on lpcware.com. So if you're doing an NXP project, I strongly recommend that you check out LPCware. Some of the stuff may be on nxp.com, but you can be sure that it's going to be on LPCware. Okay, so as you're doing graphics, one of the things that you're often faced with is, will I be able to do what I want to do with this graphics controller? So we provide a bandwidth calculator also on LPCware, where you can put in what kind of resolution, what kind of panel size, what kind of refresh rates, those kind of things, and it'll give you, how much bandwidth is being used on, say, the external memory controller. So it's a very, very handy little spreadsheet that is available for free on LPCware. And then we have a bitmap converter utility. So this converts bitmaps into C code. Really useful for importing things, but you don't want to use this if you're really concerned about memory space. It's not compressed, they're not compressed images. So, but if you're just trying to pull some images into your application and you've got plenty of external memory that you can store these things in, then this is a nice little free tool. Okay, so the demos we'll be doing will be based on the LPC1788 board from Embedded Artist, and that's also what we're giving away for those of you who haven't signed up yet. But there are also boards available from IAR, and there's from a company called Future Design that's down there in the bottom corner. They make what's called a Muse GUI, which is a panel that's already pre-populated with application code. It's built on FreeRTOS, and they will even sell you the modules. They come in different sizes. I think 3.2, 4.3, and 7-inch sizes, where you can even buy them in volume and just plug it right into your application as well if you don't want to do any of the development. For IDEs, it's supported by our LPC Expresso, the Eclipse-based IDE that we have, but also Kyle, CodeRed, IAR, Atolic, Raleigh. So almost all the major guys that are out there support our 1788 and almost all of our Cortex-M devices. And then JTAG, if it supports Cortex-M3, it supports our parts. And I just wanted to touch on this briefly. For those of you who don't want to even get into this, we do have a partner called IS2T. They're a French company, and they offer Java GUIs. So it's object-oriented programming, virtual machines, and it's optimized around the 1788. So if you want to write in a higher level language like Java, it makes portability very easy. It's fairly optimized application that takes about 160 kbytes of flash on there. So if you're interested in that, you go to is2t.com, and they have board support packages already for the LPC 1788. Okay, so if there are no questions, I'm going to turn it over to Dale, and he's going to walk through the application and how he developed it, and then what you can do to modify it to work in your application. Thank you.
Hello. So I was responsible for making a couple of demos for this show. So this is the first time I've used this product. So I had to learn how to use it, and I found that it was quite easy to use, using the utilities to produce quickly prototyped demos, running them in Windows simulation. I was able to create executables and email them around to other people to get ideas. And let me show you what I did. I have a very simple program that I'm displaying a couple of bitmaps, which are the gauges, and I'm updating a little needle in the gauges constantly. The RPM is taking its data from a pot on the board. The rest of the things you see on the screen are widgets, which are part of the window manager. I have a couple of sliders, the graph windows, and I don't have buttons on this one, but you know, it's got buttons and everything else you would expect from a window manager. So what this is doing is it's running in a tight loop, calling the window manager over and over again, and the window manager, whenever it receives inputs for the widgets, it sends messages, much like a regular Windows machine, and you respond to those messages. For instance, when I move the slider, each time I move the slider, it sends a message telling me what the position is. Then I take the value of that slider and I update the little number next to it. Oh, thank you. And then I have another piece of code that turns that text widget that says alarm on and off. Yeah, very, very simple stuff. I'm sure everybody's worked with this sort of thing before. Basically, is the Windows library controlling everything, or am I reading the data from the SPI port, which is where the touchscreen data is coming from, and feeding it to the Windows library, where it responds to it and sends a message out? Well, we're providing you a binary library, and we provide you with a set of configuration files that go with it that integrate into the system. So the library is going to be calling to routines to get the status of the mouse, for instance. In this case, it'll be reading the value of an SPI port. And that's going to send XY values to the library. The library knows where the slider is. It knows what the current state of the touchscreen display is. It makes the decision on whether the widget is receiving the input or not, but it's my driver code that's actually sending it those XY coordinates. Okay? All right. And that's the way it works with everything in here. Okay? So in order to create this demo, I used a utility called GUI Builder to produce the first prototype. And this is what it looks like. Again, I'm sure everybody's seen these sort of things before. I can select a button. Let's see. Oh, I have to decide whether it's a dialog or a window, and then I can the dialog I can select certain attributes like the color of the text. I can make it red, for instance, and I can position the text. Let's say I put it in the middle of the text bar, title bar at the top. I can change the font, and I'm just right-clicking on the window. Say I want to make it this font here, right? So let's say I want to put a button on here, so I can position a button down here, and let's say I want to make this a cancel button, right? So now I've got a cancel button, and I can do that with all the things that they have on here: sliders, radio buttons, scroll bars, all kinds of stuff. Very typical stuff. This program, when I save the file, it will create C code, and the C code will have it'll have a main loop. It'll have I'll take it back. It won't have a main loop. It'll have a function that you call from a main loop. It'll initialize the dialog window. It'll initialize all of the parameters. For instance, there'll be some code that puts the word cancel in this button, for instance, and then it contains the window messaging processing structure, which will handle all the logic. For instance, when you push the cancel button, you can tell it to do something whenever the button gets pressed. Okay. So here is this is the file that I created for that industrial demo you just saw. Notice that the gauges are not there. This is because I use code to put the gauges up separately. However, the gauges, I use the bitmap converter to create the gauges, and actually you can create compressed images. So definitely I suggest that you make it compressed and not raw bitmaps. There's a limited amount of memory on these little parts. Notice that the graphs are not here. This tool does not support graphs, but in order to get the look and feel correct and right, I just put a text box here. And in my code, I grab the size and the position of these text boxes whenever I manually create the graph and position it. That way I can get a feel for where they are. Now, okay, so then I first got all the buttons and the sliders and the text box widgets and everything in the right place. And then I went over to the simulator, which is in Visual Studio. We have project files for Visual Studio 6 and Visual Studio Express 2010, which is free. And this is what the code looks like. It's here's the initialization section. This is here's the message processing code here. See, notification value changed for the slider, for instance. So you come in here and you get the value of the slider, and I have a little piece of code that updates the slider. And then when I run it, it looks just like the thing on the board, and that's always the case. It's very nicely done. Now when I was tasked to produce these two demos, and I made them both and very quickly, I used the GUI Builder in both cases. I built it, and then I simulated it, and then I sent executable versions of these in an email to Gene, and he came back and said, that's crap, fix it, change it, move buttons around, move the slider, and it didn't look this nice, it was a lot worse before. So we went through 3 or 4 different iterations on both demos, and it was very, very easy to do, and I got 99% of the code done in simulation before I ever had to put it on the board. And putting it on the board was quite easy because I already had example board support packages for this particular hardware. I just took the existing demo that was in you'll find in the board support package, and I swapped it out for this one. And with very, very little effort, it just dropped right in and ran. And the only code that I added in was the code that turned the pot. Now in this case, I want to be able to run that gauge, so emWin also is able to get input from Windows. So I've hooked up keys, and I can move the gauges with keys. I can also move the sliders with my mouse. Okay. And I have a little if-def in my code that says, if I'm running in Windows, take the data from the mouse and the keyboard. If I'm not running in it, then the RPM gauge gets data from the pot, and the sliders get it from the touchscreen. Okay, so this is where you get it. And this video and this slideshow and the code that you're seeing, as well as the packages, are going to be available to you, so you can go back and you don't have to write it down if you don't want to. So what you get is you get the board support packages. They're all designed to run on one board, and pre-compiled libraries for 4 different compilers and 5 different core types, and the simulation environment for Windows, and related source links. So I just said that's what's available in the packages. Okay, there's different libraries or different zip files. So this is what you do to get it. You go on to that website and you select the board support package. This is the first one. It gives you a zip file. In it is an executable. You run the executable, and you're going to have to click through this software license agreement. You say I agree. You say next, and it'll deposit another zip file into wherever you decide to put it. This is the contents of the zip file. This is the Segger documentation. All the project files for all the compilers are in this folder. And the application and config are the two main folders you're going to want to deal with. So the application has the demo application that you'll see. Config has the configuration files. Remember, we give you a library, a binary image, and so these configuration files will let you port it to different displays, different microcontrollers, and also allow you to configure the emWin library. Okay. This folder right down here, system, is a collection of microcontroller drivers for the 1788 in this particular case, things like SPI drivers and things like that. How to build it, all the project files are back in that folder. And for 3 of these tools, you can just double-click on the file. And actually, I don't have the Rally one, but there's also a 4th one, Rally. And for Espresso, you don't double-click on the C project file. There's a different way to do it. You'll have to learn how to use that tool. IAR had the most hands, by the way. Okay, so emWin has a collection of display drivers. There are two types of display drivers. One of them is a linear driver that relies on an LCD controller that's embedded in our chips. And we have LCD controllers in 1778 and the 18XX and the 43XX families. And the 13s, they have them? 2478s, yeah, an ARM 7. Okay. Now, emWin will work with all of our parts, just that don't have controllers, but then you would use these display drivers. The Flex Color is the one that's going to support the majority of displays out there that have their own controllers and their own bitmaps built in. So in this case, emWin is smart enough to know how to interface with these, with the particular drivers. And then actually you'll go to the manual and it'll give you a long list of all the different displays that are out there for each one of these libraries. And it knows the most efficient way to communicate with that controller over an SPI bus, I2C bus, whatever. And it'll basically configure it and feed it the bitmaps. Okay. So the linear driver, there's several different versions of it, and basically the parameters you feed it determine what type it is. So the bits per pixel is the last argument in the name, and whether the X and Y axes are mirrored or swapped, you determine that by, as you can see there, filling in the orientation section. The demo that's on that small display, actually I had to swap the X-axis to make it look proper. Okay. This is how emWin is initialized. Your main program calls a function called GUI init, and that's pretty much it. It runs some internal initialization in the library, and it comes out the other end in a file called lcdconf.c. That's the file that you're going to be spending most of your time in. And the first thing it's going to do is configure the library itself, and that's where you give it the buffers that it needs to use, and you tell it how big the buffers are and the block size and things like that. And then it's going to configure the display. This is the point where you give it the display driver that you want it to use. You select the palette and you configure it. And then the display driver itself, this is the code where you give it the initialization to set up the LCD controller, your embedded or your external memory controller, set up your SD-RAM chips, and your touch controller. Okay. Okay, so the configuration is very, very well spelled out in the emWin chapter or the manual. It's very large with a lot of detail. You'll be spending a lot of time in this manual. I did. There's the 4 files down below that you're going to be spending most of your time with. They have associated header files with them as well. For instance, the GUI conf, these are the defines that you're going to set that determine the amount of memory you're going to give emWin to run and the actual buffer itself. Now, in this case, you would, I just have a simple static array there, but normally you would locate this in whatever particular area of memory you need it to run in. You not necessarily just let it determine that itself. For instance, you may want to put it in a faster piece of memory than normal. This is the display buffer, the frame buffer for the display. And this is the other block of memory that you're going to allocate. And these frame buffer sizes are going to be used by not only by the code running on the board, but also the simulator. In fact, that's 800 by 480. That's what determines this window right here. This is the steps that you would take to port the board support package that we give you online to another one of our microcontrollers. Moving it to another microcontroller is really not very difficult at all. In fact, it's quite simple. First of all of the microcontrollers that we have that have LCD controllers in them, the controller is the exact same block. So you don't really have to change any of the code that sets up and drives the LCD controller. The external memory controller is the same way for all the Cortex parts. For the ARM 9, it's a little bit different, but it's not that big of a deal. All right, and the file lcd-conf.c has all the code that drives these things. So one thing that you will need to change is the pin muxing. So the signals come out on different pins on different parts, and so you'll need to change those values. And that's just a simple matter of going into the manual and determining which pin is for which signal. And then the code is pretty self-explanatory, how it works. And you'll need to do that for all these different interfaces. And the SDRAM itself is, it's SDRAM parts, so you're going to have to get out the manual and figure out how to do all the timing and for those parts. Okay. How to port to another display. This is a little bit more of a challenge. This is where you're going to spend more of your time. And basically, we have a single structure called LCD param, and that's going to contain information like the size of the display, the front and back porch, the bits per pixel, whether it's a 565, 555, all these different things. And you fill up this structure. In this case, in the board support package that's online, for some displays, we read it out of E2PROM, those values, but for one of them, we actually manually fill it in with numbers. And if you have a new display, all you need to do is get the data sheet out and get all those numbers and plug them into this structure, and you pass it on. That structure is used in this function called init LCD. And again, this is all on lcd-conf.c. Next steps, the installers, and again, the installers are just that little window that asks you to click on the license agreement. They're all up on LPCware. Quick start guide and porting guide. We're gonna take the information that was in the Segger manual and condense it a little bit, add some more pictures and arrows, which is always nice. They do a good job of adding pictures and arrows, and it's very easy in the guide, but we're going to condense it a little bit more, tailor it just to our parts. And that's coming soon. That'll be up there probably in a couple weeks. Evaluation boards, we're going to be porting this. The plan is to create a unified driver platform that this library is going to be placed onto. And we're going to support many, many different boards, many different processors. And all you need to do is change a configuration in the compiler, and you can move over to whatever processor you want. All the code will be the same. Okay. All right, and EE times, all the information can be found there at that link.